Welcome everybody. We are going to be starting with the Superhero League developers track. Thanks for being here. I see that we are already 17, so we hope more people is going to come with us so we can start. On the meantime, I will ask to turn off your cameras and microphone so we can see and hear the speakers on stage. Anytime you want, you can put your questions on the chat anytime you want. And welcome again to the Superhero League developers track. Once again, my name is Omar Saadoun, and I'm a blockchain software engineer. I'm part of the Eternity Americas team. I'm also here with Eric Wallstadt, our ambassador manager, who is going to be co-hosting with me. And just as a remembering of what Eternity blockchain means, we have to remember that it's a blockchain that has been built from scratch to be the next blockchain generation with cool features like state channels, oracles, naming system, and really fast and low-cost transactions, and but last but not least, the best developers team. So just as a reminder, you can check, and we will share every link we have for all our documentation, our GitHub, and cool projects, and also educational material, so you can learn about it. Our agenda today is composed by 2 presentations and something very special, that it's an Ask Me Anything track at the end. Our first presentation is going to be done by Emmanuel Umeh from Nigeria, who is going to code on stage a games vending app from scratch. So follow that presentation. It's going to be cool to see how to create an app from the early beginning. After that, we have a presentation done by Fabián Hernandez. He's from Colombia, and he's going to present Franchesca.aes, a smart contract in Sophia, of course, that facilitates domestic service payments at home. And last but not least, we have Philip's Pivowarski, Pivo, for everybody who knows him from the forum and the chats, and Ulf Rieger for an awesome opportunity to ask anything we want to these rock stars and core developers that we have in the Eternity team. For now, we are going to be playing the speakers presentation. So anytime you need, anytime you want, please put your questions on the chats, and the speakers will be answering at the end of every presentation. Okay, so I wanted to present Emmanuel before starting. Emmanuel Umeh is from Nigeria, and he's a blockchain developer and Sophia smart contract mentor at the city of Jos in Nigeria. He specializes in Solidity and Sophia and has a great passion for learning. And he's also a full stack developer, specializes on React.js and Node.js. And now we are going to see how he built an app from scratch. And let's play the presentation, Eric. Thank you.
Eternity is a blockchain platform. It's used for building scalable, secure, and decentralized apps. You can check out Eternity on their official website, æternity.com. They have a lot of information about Eternity, the advantages over other blockchain platforms, some of what they offer, like state channels and all of that. You can they also have the link to their documentation, which will show you details about what Eternity is all about, their smart contract language, which is called Sophia, and how to write Sophia. So you can see some examples also on GitHub and all of that. So without much delay, we'll just go straight into the course for today. Today I'm going to be teaching you how to write smart contracts. Now, smart contracts is a piece of code that is built on the blockchain. Now, these smart contracts are self-executing contracts, and they help to serve as intermediaries between different parties that are making transactions on the blockchain. So it helps to improve relationships and ensure security between transactions. Now, to write Sophia syntax, we're going to be making use of the file editor. So just on your browser, you can go to fileeditor.nikitafox.de. I'll be putting the link in the description to this video, so you can just go straight to this link, and then it will open a web IDE for you. Now, this web IDE is basically an IDE which you can use to write smart contracts or Sophia smart contracts. It enables, it provides a lot of services, like it gives you test funds. It also connects you straight to the Eternity blockchain, and then provides you addresses and accounts for you to use and test your smart contracts. Also a place where you can actually test smart contracts, and also provides hot reloads and instant debugging of your code. So in case you have any errors, it will immediately show you that. And then also an event logs, where you can also see details about your transactions and all of that. So when you load this web ID, by default you'll see some default code. So this is just showing you the inner workings and how the whole setup of Sophia looks like. So, but for now, we're going to be clearing all of this. So you can just Control A and then delete everything. Now, for this tutorial, I'm going to be showing you how to build a game selling DApp. Now, this game selling DApp is going to be very simple. It's going to be where a user can come and upload the game and then sell it to interested parties via the blockchain. Now, before we jump into the code, I want to introduce you all to IPFS. So IPFS stands for Interplanetary File System. IPFS is basically a decentralized storage platform where you can actually upload data and store it in decentralized way. Now, the reason for IPFS is to prevent you uploading data to uploading data to the blockchain, because uploading heavy files and images to the blockchain actually costs a lot of gas fee, and then lot of gas fee, and then it means you're going to spend a lot of cash trying to perform a transaction or store data on the blockchain. So IPFS comes to solve all of that, and then it's very easy to use. So what we're going to be using IPFS to do, IPFS is basically going to collect the user's image or whatever he wants to upload to the blockchain, and it's going to save it on the blockchain. Then it's going to provide a hash to us. Now that hash is going to be provided to the smart contract, and going to be stored on the blockchain, which you can use to access the file. So this what an IPFS hash looks like, right? And then we'll go into details as we go on. So let's just go back to the code now. To write a smart contract, you have to first write the keyword contract and the name of the smart contract, which in our case is going to be gamify, or whatever you want to name your smart contract. Now, I'm going to introduce you to something called a record. Now, Eternity first of all has documentation for their whole functions and everything that they have inbuilt. You can find it on their GitHub account, which I'll show you in a bit. But they have inbuilt they have the whole setup of all the functions and everything that will help you get up to track when writing smart contracts. So they have they'll show you how to write contracts, how to define contract keywords, things like entry point, mutable states, stateful functions and all of that. So everything is on the documentation. All these documentations, I'll put them all in the description to this video. Okay, so let's just get back to the code now. After we define the contract gamify, right, we're going to define the structure in which every game on our platform is going to be stored. Like, so we're going to say use the keyword record, then the name of the game, which is, or the name of the record, which in our own instance is going to be game, right? And it's going to be equals to, it's going to basically be an object. Now Sophia uses indentation, so we have to come here and indent. And also the name of functions or records in Sophia always starts with small letter. So when we change that, the error goes away. So now for our game, we're going to be storing some things like the name of the game, and then we have to declare a data type. So Eternity, or Sophia rather, has a lot of data types, include strings, integers, booleans, addresses, and all of that. We should get into some of them as we go. So for the name of the game is going to be a string. We're going to have the price of the game, which is going to be an integer. We're going to have the owner address of the game. That's the person that actually owns the game, and his data type is going to be an address. We're also going to have the file hash, which is going to be provided to us via IPFS, as I stated earlier. So this is going to be a string. We're also going to have a purchased, which is going to be true, which is going to be basically be a boolean, sorry, by default. So for now we have this simple structure which has a name, a price, owner address, file hash, and then purchased. We should also have a description of the game, as this will help us understand more. So the description is also going to be a string. So right now we have this basic record, which is basically structure of how each game is going to be like. So next up, we're going to have a record state. And now this record state is basically going to handle all our changes and all our anything we're going to save to the blockchain is going to pass through our state. So now in our record state, we're going to use we're going to define a mapping. Now we're going to say games, which is going to be all the games we have on our we have saved on our blockchain platform, is going to be a map of an integer to this structure or this record here called game. Now what this means is that every game here that is saved will get mapped to an integer, and this integer will start from 1 to the length of games that we have. So with that being done, we're going to go straight into writing some of the functions. So like I said, Fire Editor provides real-time compilation. So as you're writing your code, it actually compiles and gives you all your issues and all of that to actually fix. So you might actually have this error. It says the init function code runs blah blah blah. Now this is basically telling you that your init function has not been declared. Now your init function is basically going to be the function that calls immediately your smart contract is deployed, and every your smart contract or your Sophia smart contract must have an init function. So we're going to define a function here. That's the init function. We're going to use the keyword entry point. So entry point is the keyword for defining a public function in æternity, or in Sophia rather. So entry point is going to be an init function, and then it's going to be equals to an object, and we'll leave that at that for now. Now let's create some of the functions. Now okay, in an init function, when the contract is deployed, we want the number of games, or the mapping of games, that's all the games we have, to be empty. So inside our init function, we're going to declare that we're going to say games is going to be equals to an empty object. So that means that anytime our contract is deployed, our games is actually going to be empty. Alright, so now we're going to go straight into the code. Now we're going to create a couple of functions, which is going to be, we're going to comment. You could just put 2 slashes and then you can comment. So we're going to create an add game function. Also going to create a get single game function. It's a return one single game from all the list of games we have, or from the entire list of games we have. We're going to create a function to get all the games that we have, and then we're going to have a function to purchase a game. These are the four basic functions that we're going to be creating in this tutorial. The functions to be created. Alright, so let's begin. Let's begin with the first function, or rather let's begin with the get all games function. So to define a function, like I said, you're going to use the keyword entry point. So you're going to be entry point. I'm going to give it a name, which is going to be get all games, and then it's a function, and it doesn't take any arguments, so we'll leave this parenthesis empty. So it's going to be equals to, right, then the brackets, and I'm going to indent this. So how do we return all the games? So to return all the games, like I said, these games is basically storing every game that we have and mapping it to an integer on our own platform. So we can easily just return these games that we have in our state, and that will be that. So we can say we can say state dot games, and this will return all the games basically we have on our platform. So it shows us an error, meaning this is not meant to be there. So state the games, and this returns all the games that we have stored on our platform. So now let's create a function to, like I said, Sophia is a very easy smart contract language, so you can easily write smart contract languages on Sophia just like that, and it's very, very quick to set up. So to get the second function we're going to be creating is going to be get single game. So we're going to define another function, entry point, and it's going to be called get single game, and then it's going to be equals to. Now this get single game is going to take an argument. Now this argument is going to be an ID, and it's going to, data type is going to be an integer. Now this ID, we're basically going to use it to actually get because our games here is mapping an integer to a game. So now this ID now is going to be either a number, either one to whatever, and it's going to pass this number into this game's mapping to find the game that has the mapping of that same number. So that's basically what we're going to be doing here. So we can just come here and say to get single game, right? We're going to do a switch statement. Now the switch statement, inside the switch statement, we're going to do a map.lookup, and then inside the map.lookup, we're going to look up this ID, and then we're going to search for this. Eternity is a blockchain platform. It's used for building scalable, secure, and decentralized apps. You can check out Eternity on their official website, æternity.com. They have a lot of information about Eternity, the advantages over other blockchain platforms, some of what they offer, like state channels and all of that. You can they also have the link to their documentation, which will show you details about what Eternity is all about, their smart contract language, which is called Sophia, and how to write Sophia. So you can see some examples also on GitHub and all of that. So without much delay, we'll just go straight into the course for today. Today I'm going to be teaching you how to write smart contracts. Now smart contracts is a piece of code that is built on the blockchain. Now these smart contracts are self-executing contracts, and they help to serve as intermediaries between different parties that are making transactions on the blockchain. So it helps to improve relationships and ensure security between transactions. Now to write Sophia syntax, we're going to be making use of the file editor. So just on your browser, you can go to fileeditor.nikitafox.de. I'll be putting the link in the description to this video, so you can just go straight to this link, and then it will open a web IDE for you. Now this web IDE is basically a an IDE which you can use to write smart contracts or Sophia smart contracts. It enables, it provides a lot of services, like it gives you test funds. It also connects you straight to the Eternity blockchain, and then provides you addresses and accounts for you to use and test your smart contracts. Also a place where you can actually test smart contract, and also provides hot reloads and instant debugging of your code, so in case you have any errors it immediately show you that. And then also an event logs where you can also see details about your transactions and all of that. So when you load this web ID, by default you'll see some default code. So this is just showing you the inner workings and how the whole setup of Sophia looks like. So but for now we're going to be clearing all of this, so you can just Control A and then delete everything. Now for this tutorial I'm going to be showing you how to build a game selling DApp. Now this game selling DApp is going to be very simple. It's going to be where a user can come and upload the game and then sell it to interested parties via the blockchain. Now before we jump into the code, I want to introduce you all to IPFS. So IPFS stands for Interplanetary File System. IPFS is basically a decentralized storage platform where you can actually upload data and store it in a decentralized way. Now the reason for IPFS is to prevent you uploading data to uploading data to the blockchain, because uploading heavy files and images to the blockchain actually costs a lot of gas fee, and then lot of gas fee, and then it means you're going to spend a lot of cash trying to perform a transaction or store data on the blockchain. So IPFS comes to solve all of that, and then it's very easy to use. So what we're going to be using IPFS to do, IPFS is basically going to collect the user's image or whatever he wants to upload to the blockchain, and it's going to save it on the blockchain. Then it's going to provide a hash to us. Now that hash is going to be provided to the smart contract and going to be stored on the blockchain, which you can use to access the file. So this what basically what an IPFS hash looks like, right? And then we'll go into details as we go on. So let's just go back to the code now. To write a smart contract, you have to first write the keyword contract and the name of the smart contract, which in our case is going to be gamify or whatever you want to name your smart contract. Now I want to introduce you to something called a record. Now Eternity first of all has documentation for their whole functions and everything that they have inbuilt. You can find it on their GitHub account, which I'll show you in a bit. But they have, you know, inbuilt they have the whole setup of all the functions and everything that will help you get up to track when writing smart contracts. So they have they'll show you how to write contracts, how to define contract keywords, things like entry point, mutable states, stateful functions, and all of that. So everything is on the documentation. All these documentations, I'll put them all in the description to this video. Okay, so let's just get back to the code now. After we define the contract gamify, right, we're going to define the structure in which every game on our platform is going to be stored like. So we're going to say use the keyword record, then the name of the game, which is, or the name of the record, which in our own instance is going to be game, right? And it's going to be equals to, it's going to basically be an object. Now Sophia uses indentation, so we have to come here and indent, and also the name of functions or records in Sophia always starts with small letter. So when we change that, the error goes away. So now for our game, we're going to be storing some things like the name of the game, and then we have to declare a data type. So Eternity, or Sophia rather, has a lot of data types, include strings, integers, booleans, addresses, and all of that. We should get into some of them as we go. So for the name of the game is going to be a string. We're going to have the price of the game, which is going to be an integer. We're going to have the owner address of the game. That's the person that actually owns the game, and his data type is going to be an address. We're also going to have the file hash, which is going to be provided to us via IPFS, as I stated earlier. So this is going to be a string. We're also going to have a purchased, which is going to be true, which is going to be basically a boolean, sorry, by default. So for now we have this simple structure which has a name, a price, owner address, file hash, and then purchased. We should also have a description of the game, and this will help us understand more. So the description is also going to be a string. So right now we have this basic record, which is basically structure of how each game is going to be like. So next off, we're going to have a record state. And now this record state is basically going to handle all our changes and all our anything we're going to save to the blockchain is going to pass through our state. So now in our record state, we're going to use we're going to define a mapping. Now we're going to say games, which is going to be all the games we have on our we have saved on our blockchain platform, is going to be a map of an integer to this structure or this record here called game. Now what this means is that every game here that is saved will get mapped to an integer, and this integer has to start from 1 to the length of games that we have. So with that being done, we're going to go straight into writing some of the functions. So like I said, Fire Editor provides real-time compilation. So as you're writing your code, it actually compiles and gives you all your issues and all of that to actually fix. So you might actually have this error. It says the init function code runs blah blah blah. Now this is basically telling you that your init function has not been declared. Now your init function is basically going to be the function that calls immediately your smart contract is deployed, and every your smart contract or your Sophia smart contract must have an init function. So we're going to define a function here. That's the init function. We're going to use the keyword entry point. So entry point is the keyword for defining a public function in entirety, or in Sophia rather. So entry point is going to be an init function, and then it's going to be equals to an object, and we'll leave that at that for now. Now let's create some of the functions. Now, okay, in an init function, when the contract is deployed, we want the number of games or the mapping of games, that's all the games we have, to be empty. So inside our init function, we're going to declare that we're going to say games is going to be equals to an empty object. So that means that anytime our contract is deployed, our games is actually going to be empty. Alright, so now we're going to go straight into the code. Now we're going to create a couple of functions, which is going to be, we're going to comment. You could just put 2 slashes and then you can comment. So we're going to create an add game function. Also going to create, also going to create a get single game function. It's a return one single game from all the list of games we have, or from the entire list of games we have. We're going to create a function to get all the games that we have, and then we're going to have a function to purchase a game. These are the 4 basic functions that we're going to be creating in this tutorial. The functions to be created. Alright, so let's begin. Let's begin with the first function, or rather let's begin with the get all games function. So to define a function, like I said, you're going to use the keyword entry point. So you're going to be entry point. I'm going to give it a name, which is going to be get all games, and then it's a function, and it doesn't take any arguments, so we'll leave this parenthesis empty. So it's going to be equals to, right, then the brackets, and I'm going to indent this. So how do we return all the games? So to return all the games, like I said, these games is basically storing every game that we have and mapping it to an integer on our own platform. So we can easily just return these games that we have in our state, and that will be that. So we can say we can say state dot games, and this will return all the games basically we have on our platform. So it shows us an error means this is not meant to be there. So state.games, and this returns all the games that we have stored on our platform. So now let's create a function to, like I said, Sophia is a very easy smart contract language, so you can easily write smart contract languages on Sophia just like that, and it's very very quick to set up. So to get the second function we're going to be creating is going to be get single game. So we're going to define another function, entry point, and it's going to be called get single game, and then it's going to be equals to. Now this get single game is going to take an argument. Now this argument is going to be an ID, and it's going to, data type is going to be an integer. Now this ID, we're basically going to use it to actually get the, because our games here is mapping an integer to a game. So now this ID now is going to be either, it's going to be a number, either one to whatever, and it's going to pass this number into this game's mapping to find the game that has the mapping of that same number. So that's basically what we're going to be doing here. So we can just come here and say to get single game, right? We're going to do a switch statement. Now the switch statement, inside the switch statement, I'm going to do a map.lookup, and then inside the map.lookup, we're going to look up this ID, and then we're going to search for this ID. And then we're going to be checking for this ID. We're going to be making a map.lookup with this ID to our state.games, which is right here. So it's going to check these games and find out if we have this ID inside actually game with this ID inside the state.games, right? And then we want to return our value. So if we actually find, if there's actually none, right, we actually want to abort with the message game with this ID does not exist. And then if we actually find something, we have to return it. So we'll say sum x, I'm going to return x. So with that, we have gotten our single game. Now just this error after we declare init function did not go away. So this can be sometimes as a result of poor connection, or sometimes it can just be an issue from the editor itself. So after you fix an error and it doesn't go away, still showing you in the compilation issues, you can just refresh the page, and then hopefully the error should go away. So the error is gone. All right, so we can continue testing. So now so I've created a function get all games, and we've created another function get single game. Let's go on to other functions which include add games. Now for this get single game, there's another way to do it, right? You can actually just easily search or just return. You can easily, let me just show you. You can easily, let me comment all of this out. You can just easily say return state.games with the ID you passed. So it's basically going to return the game with this particular ID. But the problem with writing your function this way is that if it doesn't find a game with this particular ID, it breaks. So that's the reason for this switch statement. So I'm going to comment this back and comment this. So I'm just digress a little bit so you can understand. Now like I said, Sophia is a very simple smart contract language and very very simple to learn. So just follow along and you get a hold of the entire structure. Now the next function we're going to be creating is going to be an add game function. Now like I said, to define the function, you're going to use the keyword get the right entry point. So when you say entry point, I'm going to call the function add game. And then now this add game is going to take a couple of arguments, and these arguments are going to be depending on what we have here in our record. So we know in our record, a record of game, we're going to have a name, a price, an owner address, file hash, which is going to be provided for us from IPFS, So I can just do this provided from IPFS, and then purchased and description. So we're going to need all of that. Some of this, like owner address, is going to provided to us by Sophia themselves, or by Sophia smart contract language itself. But let's just begin. Now for the first argument we're going to pass is going to be a name. Now the name is going to be a string. Now I'm going to just put the quote here to show you that this is actually a local variable, and it's not the same with this name here, so that we don't have confusions with the naming system. So we have the name string, or is a string. Then we also need to pass in the price, which is going to be an integer. What else do we need to pass? Also we need to put the single quote here, and also now this owner address, we're not going to pass it because it's going to be provided to us via Sophia, which I'm going to show you in a bit. File hash, we're going to pass that as well. So we're going to come down, put a comma, file hash, and file hash is going to be a string. We also have purchased and finally description. So purchased and description, let's just pass in description, which is going to be a string, and then purchased, we're not really going to pass, the user is not going to pass it because it's going to be defined to us, or defined by default. It's going to be false, and when it's purchased, it's going to be true. So it's going to be a default value and it's going to change depending on what happens. So we're going to put an equals to here, and then I'm going to indent. Like I said, Sophia uses indentation, so you can just use the tab key to indent. I think it indents 4 lines. Let me be sure. 1 2 3 4, yeah, 4 spaces. So you indent 4 spaces with the tab, so you can use that for indentation. Now what we're going to do is that we're going to first of all create a structure that is very simple, that is similar to this, so that we can then save it. Now what I mean is that we're going to create a let binding here. We're going to say let new game is equals to, going to be an object, and then we're going to pass in all these details and what we need. Now we're going to say the name, which is this name here, right, is going to be equals to the name we passed in as an argument, which is with the quote, which is this name here. So we're going to do that for the rest of them. So we're going to have the price, which is going to be equals to price. I'm going to put a comma here, if not we'll have errors. Like I said, it compiles in real time. So this error says let's binding at column 38. We're going to be fixing that in the jiffy in a moment. So so we have name, price. The next thing we're meant to pass actually the owner address. Now how do we get the owner address? Like I said, the address is basically your identity on the blockchain, because the blockchain provides anonymity, so you're basically anonymous on the blockchain. This way addresses come in play. So the blockchain platform provides you an address, which is an encrypted hash, which you can use to interact, or people can use to interact with you via the blockchain. So people can send you, crypto funds and all of that through your address. Now Eternity has, or Sophia has, a inbuilt function for getting the address of an owner, or an address of a person that is calling a particular product, or products basically. So to do that, let's head over to the documentation right here. I think we just look for now this function called call.caller is an inbuilt function on Sophia that provides you the address of the person that is calling a particular function. So we're going to use that call.caller in our own particular setup. So let's just head back to the code. Owner address is going to be equals to call.caller. So this is going to provide the owner address as the person that called this function, which is going to be something in this format. All right, so let's keep on going. We're going to have the file hash, which is going to be provided to us via IPFS, interplanetary file system. So file hash is going to be equals to the file hash we passed here. So it's meant to have a single quote here. So file hash, and then also going to have a description, which is going to be equals to this description here with single quote. I don't know why I keep forgetting to add that. So it's going to be description with the single quote. And I think that's all the details we need to pass, if I'm correct. So we have okay, then we need purchased. Is the game purchased or not? So we're going to have that come out. We're going to have a purchased, which is a boolean, and a boolean means either true or false. So by default, first it's meant to be false because the game has not yet been bought. So with that, we've created our identical structure to this record. So now we have to now save this. Now to save this, we have to remember, like I said, all changes and everything we want to make, addition and updates are going to go through our state, because all our games are basically stored right here, then stored on the blockchain. So if we're going to add a new game, as we notice here, our games is a mapping of an integer to a particular game, meaning that each game has an integer like which is either 1, 2, 3, and so on, depending on the hierarchy of the position of the game or the time it was created. So our first game will have an index of 1, second game will have an index of 2, and etc. So if you want to add a new game, and let's say we have 3 games, want to add a new game, that new game will have an index of 4, and we have to define that. So what we're going to do is that we're going to say we're going to call a function, or create a function rather, up here, that gives us the length of the length of the games that we have, that's the number of games that we have, and since our index of each game is starting from 1, it means that the length of the game is basically the index of the last game. I don't know if you understand, but as we go on, you understand. So let's create a function entry point. We'll call it game length. You can call this anything you want. So, but just know that every function starts with a small letter. So game length is going to be equals to, and now we're going to return. Now, Sophia also has, if you go back to the docs, they have some functions you can call on mappings. So let's just go over. I think there's quite a lot, but what we're looking for is map dots. Oh. Okay, so sorry for that. So what we're looking for is map dot size. Okay, I'm having quite a bit of an issue finding it. But Sophia has an inbuilt like operations on mappings, and since in here, okay, here we have things like map.member. I don't know where they put the rest, but sorry, give me a second here. Okay, I can't see where they put the rest, but we'll just let's just continue. I'll just explain as we go on. So in here, Sophia has something called map.size, which is basically going to return us the entire length or the entire size of the mapping. So we're going to say map.size, and then we're going to pass in this game since it's a mapping. So we're going to say state.games. So this function should return us the length of games that we have. So now let's just go back to the code. It still tells us let binding at line 42. So after you create a let binding here, something else is meant to follow. Like after you define new game versus this, it's asking what next do you want me to do. So what we're going to do is that we're going to create another let binding here. We're going to say let length, right, equals to Now, remember this function we just created gives us the length of games that we have. So first of all, I want to get the length of games that we have. So let me just copy the name of this function and then put it here. So let length equals to this. So it's going to call this function, right? Now, remember, as when we start, the length of games we have is basically 0, but we don't want a game to have an index of 0. So we're going to say +1. So this is basically going to start our indexing from 1. Now, after we've done that, now we can basically go to work. Now we're going to use something called put brackets, then state, then curly braces. Now this put state basically means you should make changes to this state, anything inside this state, but which we're going to define what changes we want. So as we put this put state, our compiler always throws us an error. It says cannot reference stateful function put at whatever non-stateful function at game. So what they basically mean is that any once you call this put state, or things like change or spend, which are stateful functions, it's going to require you that function they are being called in has to be stateful. So with that clears that error. Okay, now let's go back to work. So we're going to say put state, right? Now this put state, when you call this state here, it gives us access to everything inside our state, so we can get access to these games. So we can say put state games. Now we want this new game to be put in a particular place, like a particular ID on the blockchain. Want to be saved with a particular ID. So since this length here is going to be the length of the entire games we have +1, meaning that I've created like a new room for this new game to be added. So we're going to say put state games with an index of length, which is this length we created here, right? And then it's going to be equals to this new game that we created. So we can just pass in new game here. And with that, you have created your first or let's say you're halfway through your first Sophia smart contract. So like what we basically did, we just appended a new game to the list of games that we already have here in our state. Sorry. Okay, so now I've been writing a lot of code. Let's just go into straight to the testing so we can see how it works. Now in order to test your smart contract, all you have to do here is come here and click on deploy and wait for the deployment process to happen. Now if you click on this event logs, it will give you a list of logs of what is basically happening. Now it tells me contract deployment failed, which I do not know. Okay, let's just reload the page a bit and try and deploy again and see what happens. So you just Control R and reload. This is my tab here. Okay, so let's try and deploy again and see what happens. Okay, so it says contract successfully deployed, so that's fine. Now it provides this instance of the provides this instance for you to be able to test all the functions that you've created that are available publicly. Like I said, this entry point is for creating a public function. There are also other functions like private, which are only called internally inside your smart contract, but functions with the keyword just entry point can be called outside your contract. So now we have about 4 functions we have created, which is quite a lot for alright, but you get the hang of it as we go. So now we have these functions: get all games, get game length, get single game, add game. So we're going to test all of this. Now when we call this get all games, or let's start with game length. When we call game length, we're meant to have a return value of false, because Sophia once it calls a particular function and it doesn't get a return value, or it gets a value of 0, it tells you it gets a return value of false. And we haven't created any game, so our game length is going to be 0. So let's just test it out. Click on call locally and it gives you a return value of false. Also in your logs it tells you call successfully, which is fine. Alright, if we say call or get all games, let's see what we return. It returns value of false as well, because we don't have any game saved. So and if we okay, so let's go straight to adding of a game. Now to add a game, these 4 fields they created for us are the fields that we passed in as arguments. So we passed in the name a price, a file hash, and a description. So we're going to have to pass in all of that. So first thing first is going to be a name. I'm a Call of Duty fan myself, so I'm going to name of the game will be Call of Duty. The price is going to, let's say, 5,000 ATOS. ATOS is the smallest value of cryptocurrency, short for AE. So let's just say 5 AE basically, because 5 AE, because I'm looking at my all right. So 5 AE, and our file hash, remember, it's going to be provided to us via IPFS. So this is going to be provided to us via the front end. So when we get into that aspect, you understand where the file hash is coming from. But for now, we can just type in anything, right? And then for a description, what is Call of Duty? Let's say it is a first-person shooter multiplayer game, just for fun. So let's click on send transaction and see what happens. So if the transaction is loading here and waiting for it to give us a value in our logs. Okay, so it says call successfully, and then it gives a return value of false because we're not returning anything. So this means that our game was actually added. So how do we find out if our game was actually added? Let's come back here and get a game length and see what happens. So sometimes this might take some time depending on your network connectivity and other external factors. Okay, so our game length gives us a return value of 1, meaning 1 game was added. So in that way, we can actually prove that a game was actually added to the blockchain via our smart contract. So let's try and get all the games that we have. It should return us an object with just 1 game, which is just and it has an ID of 1, right? And then it has a description, first person multiplayer, file hash, which was rubbish. Then Call of Duty, there's the name, owner address, which is going to be, remember, call.caller provided this address from us, which is basically the address you use to connect to the node, that blockchain node, and then the price, and then purchase default by default. So that proves that our functions are working. We can go ahead and test it with another game. So let's try PUBG for those battle royale fans out there. Let's say price is 3 because it's not as good as COD, not as good as Call of Duty. We can pass in anything here, and then we can say it's battle royale multiplayer game, and then let's create transaction and see what happens. So it says return value of false, but back down in our logs it says call successful, which means that, and then which means our game was added successfully, and we can come and call the game length, and let's see if the return value increased to 2. Okay, and so our return value is 2, meaning we have 2 games now registered. And then if we call our get all games, we should get all the games, 2 of them returned. Now this function, we haven't really tested it, so we can test it with when we're passing in the ID of the game. So like this game here, which is Call of Duty, has an ID of 1. The new game we just added has a ID of 2. So if we want to get only this game, which is Call of Duty, we can come and pass it to our get single game function, which has the ID of 1, and call locally. Now this function is just going to be handled in our backend, so the user won't actually, it has all of this, but as we go, you get the hang of it. So it returns us Call of Duty, the first person multiplayer game, and all of that. So that proves that our code is working. So in case you don't like this, like I myself, I don't like seeing this return value of false, you can just come down here, maybe after your add game function, you can just put double quotes, and then whatever you want as a return value. So I can say return game added successfully, right? And so anytime we call our add game function, if it calls successfully, to return this text for us, game added successfully, which is really fine. So with that being that, so we've created this function, right? So we've created this, we've created a get single game, or get all games, and now last and not the least, we're going to create a purchase game. Fine. So now let's come down to the bottom of our smart contract, and then let's create a new function. This is going to be entry point purchase game. Purchase game. Now for this, sorry, this spelled that right. Alright, so for this purchase game, we're going to basically be passing only one parameter or one argument, which is going to be ID of the game to be purchased. Then the function will handle all other changes, like changing our the purchased value here to true, meaning somebody has bought it, and then so sending money to the owner of the game. That's tokens and all of that. So now let's begin. So the argument we're going to pass in is going to be an ID, which is actually going to be an integer, which is going to signify the ID of the game that we're trying to purchase. So after that, we're going to put an equals to and enter. I'm going to indent. Remember I told you use the tab key to indent, which is just 2 steps, I think, underneath your escape button for Windows users, for HP and Dell users too. So right, so we're going to be first thing first, we're going to get the particular game that we want to purchase. So since we've already created a function that gets us a single game, which is this, so we can just basically call this function again. So we can just say get single game. So we'll come down here. So everything on Sophia, it basically works like it's function based. So anything you want to do, you have to create a function for it and all of that. So for enables like good code reusability and all of that, so we don't have to write long code and all of that. So we can just basically call that function. So we can say let game to buy, let's just call it game to buy. You can call this anything you want. So it's going to be equals to, we're going to call this function get single game. I'm going to pass it. Remember, get single game takes a argument, which is ID. So I'm going to pass in the ID that we passed to this function to it. So it's going to be an ID. Fine. So after this, now it return. Okay, sorry, change and put this well. All right. So now it returns you the single game with this particular ID. With this particular ID. Now what we're going to do is that we're going to now make some changes to that game and also send money, or the price, pay the price of that game. So first things first is that we're going to I'm going to show you something we call require, which is an inbuilt Sophia function, which is just basically replacing the conventional if else statement. So it just means that require that this is true or this is false before doing that, else break the code. So we're going to explain what that means. So first of all, we're going to require that game to buy dot. Now this game to buy returns us an entire structure which looks exactly like this. So we can access its children props, which is like name, price, owner, address, file, description, and purchased. So we can, so what we're looking for is purchased. So we say game to buy dot purchase, require that game to buy dot purchase is not, which is an exclamation mark, equals to true. So we're going to ensure that the game is not actually, has not already been bought. Then, but if it has been bought, I want it to break the code for us with an error message. So the error message is going to be game has already been bought. So sometimes if you actually feel writing your code and then your error don't go away and you feel your code is actually correct, you can actually refresh your page. This might be due to network errors and all of that, so you don't get stuck when you're actually having the right code. Trust me, I've been there. So require game to buy purchase not equals true. All right, so that's just basically like a check for us. Then we want to change. Okay, I'm going to show you guys, let's go back to the docs. I hope I actually find this, how to actually transfer crypto or transfer AE via your smart contract. So we're going to look for chain.spend. Now down here we can see change.spend is basically a stateful function, and then I'm trying to look for probably where they defined it. Okay, they did not. So but basically what change.spend does, like you say, attempt to spend into such a contract, either a change.spend, normal spend, transaction field, and so on. So what it does is that change.spend actually sends value or transfers value from one address to another via the smart contract. So like you said, it says if a contract should be able to receive funds anyway, it has to be declared payable. So we forgot to add this. So let's go back to our code. Is what it's trying to say is that our contract, since we're handling spending of crypto and buying and selling, basically we basically need to declare our contract payable. So let's come back up here and then go back all the way up to where our contract is, and we're going to declare it payable. So that should be that. And also now the change.spend, we can actually use it in our contract. So let's come back here, come back my logs, and so now we're going to do a change.spend. Now change.spend takes in two arguments, right? It takes in the person or the address that the money is being sent to, and the amount it's going to send. So we're going to say change.spend, and then it's going to send who is it going to send to? It's going to be the owner of the game. And remember, like I said, game to buy is going to return us this basic kind of structure, so we can access the owner address. So we can say change.spend game to buy dot address, and then how much are we sending? We're actually sending the price of the game, so it's going to be game to buy dot price. I hope we're together in this. Okay, now we get a new error. Type error cannot reference stateful function change.spend in the definition of a non-stateful function purchase game. Now what it basically means is that anytime, like we did here, anytime you're either making changes to your state or you're calling a stateful function which is change.spend, you have to declare the function stateful. So with that, okay, we also have an error. It says record type game does not have a field address at line 63. Okay, so this is where the issue is. So it's not meant to be address, it's meant to be actually be owner address. Okay, so that should fix that, and our error should be gone. So now we'll be able to send the money to the owner of the game. Then also we also want that game to actually be its purchase value to actually be true, right? So but now this whole structure actually means that our purchases, you can actually purchase a game only once, which we do not want that. So we're going to make some changes, right? So inside our purchase, instead of being a bool, it's going to be an integer. I'm going to change its name to purchases, right? So it's just going to keep track of how many purchases we have on that particular game. So let's make the changes everywhere. So purchases by default is going to be 0. And then also require game dot, okay, so also we can also remove this require statement, and then okay, we should be good to go. So we want, when the game is purchased, we also want to increase the number of purchases that a particular game has. So how do we do that? We're now actually going to do a put state, right? And then before we write this put state, let us first bring out the number of purchases we have on the particular game. So we're going to say let number of purchases, you can call this anything you want, like I said, is equals to game to buy dot purchases, which is at first should be 0, right, when you're creating the game, except it has been bought before. So we're going to put state games, which is this games in our state right here, which is games in our state right here. So we're going to put state games, and then we're going to get the game with this particular ID that we're trying to purchase, right? And then we're going to target its purchases. right? And then is going to be equals to this number of purchases. And now this number of purchases is actually the same number with the number of purchases we have, so we're actually going to have to increment it by 1. So this is always going to increment the number of purchases that the game has. So with that, we're going to put state game ID purchase equals the number of purchases, and that should be that. So in our purchase game, we got the game, we sent the money that the game costs, then also we now increase the number of purchases that the game has. So with that being that, our smart contract is ready to test. Now if I actually call this function purchase game inside file editor here, I'm actually going to run into errors because the file editor is not is still under development. So the change.spend function doesn't actually work here yet. So if you want to test out this change.spend function, they have a testnet, another editor, which contracts.aeapps.com, which looks something like this. And then also, if you follow the course on Decade, this is decade.org. It's a website, very interactive website where you can actually learn how to write Sophia smart contracts and other basically blockchain technology and also skills that you need to learn. So you can check all of that, and then you can also copy the code from file editor here, and then you can also paste it here, and then okay, I think I didn't copy that well. So copy that, and then you can paste it here, and then compile, and then you can actually test your code when you deploy. So my whole aim is not to teach you how to use this testnet today. If you go to decade.org and follow the Interactive Development 101, you see a lot of interactive tutorial on how to use this whole editor, because it's right on the file editor. But you can basically test that whole function here. So let's just go back into the code. So for now, to test this function, I'm just going to comment this out. We're going to uncomment this back when we're ready. So now we can collapse this initial contract we have, and then we're going to deploy a new contract. Why we're deploying a new contract is because on the blockchain, once you deploy something on the blockchain, it cannot be changed or deleted or any of that. One of the abilities or one of the advantages of the blockchain. So we cannot make changes here. We're going to have to deploy a new contract. So we'll click on the deploy button and wait for it to finish deploying. Alright, so it gives us a new contract here, which is going to be the last contract. So we'll open it. So when we run things like get all games, we should get return value of false, because it's by default again everything is reset back to 0. So let's create a new game again. So let me think of a new game. Let's think of like Mortal Kombat. I think it's spelled with a K. So price, let's say 1 ethos. AE1 AE. What else are we passing for the add game? I'm going to pass in the file hash and the description. So let's go back. So the file hash, you can write anything there for now, and then the description, this is fight death kind of game. Very aggressive game. So so then click on send transaction, and it says return value game added successfully, and this is from the return value that I created here earlier. If you noticed, I added this game added successfully if the game to return us as a return value instead of return value of false. So the game has already been added. So we can come and say get all games. So get all games, you see that the number of purchases of the game is 0. Description is there, everything is all set up. Get game length should give us a value of 1 and all of that. So let's try our latest function we just added and purchase a game. Now this game that we just added has an ID of 1. So if we want to purchase a game, we have to pass it that same ID. So pass in an ID of 1 and click on the send transaction. So it should give us a return value of false as well, because we didn't return any value here. So let's go back down. We get a return value of false. Now we've actually purchased this game, right? So meaning our number of purchases is meant to increase. So let's check if it actually increased, which is this from 0. So let's call locally and see what happens. Now the number of purchases is now 1, meaning this game has been purchased 1 time. So with that, you can actually test across multiple games and all of that. So with that, you have, so let's uncomment this back. Remember, we couldn't test this because of file editor does not allow to test the change of spend, but what it basically does is that it sends the price is from your own wallet. It actually collects the price of the game and send it to the user, and then the user is going to return to you the file hash. Now, when you purchase the game, on the front end, you're going to receive a file hash, which is going to be IPFS, basically what IPFS gave you as a hash. So you're going to use that hash basically to get your game. So the front end is going to handle all of that, which is going to be shown in later series. So you can actually download your game via IPFS, anonymously and all of that. So with that being that you have successfully written your first smart contract to handle GameFi and buy and sell video games on the blockchain, and also host it on IPFS. With that, we've come to the end of the smart contract development course. So this is just a basic smart contract development. For there are actually a lot of other functions you can add. You can just go straight to the documentation, which I'm going to add in the description. So you can see a lot of inbuilt functions, things like mutable state, payable functions, namespaces. Like there's actually a lot of things you can do with Sophia. So you can just key into oracles as well. You can just key into this documentation and actually come across a lot of information you need to get yourself up and running on the Eternity blockchain. So my name is Emmanuel. Thank you for participating in this course.
Are you there, Emmanuel?
Yeah, I'm here.
Cool. Well, I guess we have some questions. So just let's see what we have on the chat. Otherwise, I have some questions I would like to ask you. You can turn your camera if you like.
Okay.
So I'm not the only. So I'm not the only one showing his face.
All right.
Come with me to the stage. Hey.
All right.
Hi, Emmanuel.
Hi. Nice to meet you.
Okay, so what do you think about Sophia comparing to Solidity?
Actually, setting up a smart contract on Sophia, it's way easier and faster than setting it up on Solidity, because Sophia makes everything very simple to use, and you can easily and quickly create a very good smart contract. So I actually prefer Sophia to actually Solidity itself.
Cool. Thank you. I'm also a Sophia smart contract developer, and I was wondering, what features do you think, or would you like to have on the near future?
Sorry, I didn't get your question.
If you could ask for some features, some new features for Sophia, what would it be?
Okay. Okay, I think probably because that's very tricky question, because Sophia itself is really, based on how much I worked with it, it's really very alright to use. But if a new feature is added, probably things like modifiers, and I think Sophia should have that already, but probably just a little bit of changes here and there with the whole file editor itself, the whole IDs that actually compile Sophia, probably make it a little bit better, because it's really, really nice, quite alright, but it can be improved on. And to be honest, Sophia itself is already, Eternity has really done a very good job on the whole smart contract language. Yeah. So thinking of a new feature now to be added right now is, it's a very, very tricky question for me. You get, but yeah, it's a very, very tricky question for me. So, but I feel eternity, it's really nice already.
Cool. Thank you.
Yeah.
We have a question from Tino. Tino, you would like to do it yourself, or you want me to read it?
I can ask the question myself. Yeah, that's fine.
Cool.
Yeah, I'm wondering, given you've used the various editors available and written quite some code already in Sophia, how you like the development workflow compared to your experience with other languages, and what could be improved, for instance, in that workflow, specifically maybe in the Fire editor.
Okay. The Fire editor, the whole setup is actually nice because I've worked with Remix for Ethereum, and the whole Fire editor itself, it's actually more, compact and easier to use. Also, user friendly and all of that. But like I said in the video, there are some issues with concerning the whole transfer of crypto, or calling the functions like change or spend on the Fire editor. So that really doesn't work yet, as last I checked. So if that could also be worked on, so that you can fully test a smart contract on the Fire editor itself. But besides that, the Fire editor is very, very, the whole instant compilation and all of that is very, very nice, and then developer friendly as well. So I think the Fire editor is, compared to what I've worked with, Fire editor is really, really very good job, very good project.
Cool. Follow-up question. Did you send these things which you feel are not working in the Fire editor to the author?
Okay.
No, that's right. Did you, or did you not?
Sorry?
Did you send these bugs or feature requests you mentioned to the author already?
Yes, I've done that.
Okay, cool. Thank you.
All right, thank you.
Thank you, guys. Anyone has another question? I have a last one.
Okay.
I guess you already answered a part, but you worked with the two editors. You were working with the Fire editor from Nikita. You were working on the contracts editor, mostly because of the chain code and supported feature yet. But if you have to choose between one or the other, what would you say?
It has to be the Fire editor. Like the Fire editor was, because at first, when I came to Eternity newly, it was when I finished the decade course, Moritz himself used the testnet, the contract, the Ipfs, right? So it was kind of like an issue, because you might miss a comma here, and then it doesn't tell you that, and then the error you actually get might actually look a little bit complex for you to understand, and that whole stuff was really, really frustrating. But when I actually found out about the Fire editor, that actually sped up development like a lot, because the fact that it helps me debug errors easily, and you can easily build your smart contract really quick and efficiently. So like with my eyes closed, I'll definitely go for the Fire editor. So
cool. Thanks for that.
Yeah.
Well, I don't know if there is any other answer. I think we have to move on to your presentation. Thank you very much, Emmanuel, for your presentation, for your great work, and keep with us so we can move on the other presentation. Okay, great. Well, our next presentation is from Fabián Hernandez Nieto. He's the ambassador at Bogotá, and he's a free software advocate. He's an electronic engineer, software construction specialist in Bogotá, Colombia, and he has an extensive experience in the fields of architecture and software development for the web administration of Linux operative systems. He is a project management and manager of activities of social and cultural appropriation of ICT. And as a software developer, he contributed to free software projects focused on reducing the digital breach, promoting citizen participation, and strengthening the digital positioning in non-governmental and state organizations and collaborative work groups. His presentation is about Franchesca, a smart contract for the has the title. On the meantime, Eric, please play the presentation. Thank you.
Welcome. In this video, we will explore a common use case for domestic service payments called Franchesca.aes. This is a Sophia smart contract for the aeternity blockchain. My name is Fabián Hernandez, and I hope this video helps us to learn and understand some of the tools and concepts involved in the development life cycle of Sophia smart contracts and decentralized applications. During this video, we will follow this agenda. First, we will make a review of the tools used for the smart contract development. Next, we will get into the Franchesca's use case and its motivation. In this section, we will see a graphical smart contract scaffolding with its functional pieces and the use case process description for better understanding. Later, we will interact with a local node of the aeternity blockchain by compiling the smart contract and running some operations. After that, we will review the smart contract structure with its public entry points API. At the end of this section, we will showcase and run behavior-driven testing. Finally, I want to show what is the roadmap of this use case for further development. Before we start, we need to know the right tools that will help us to have a smart contract development workflow. These tools will be part of our local development environment. As mentioned before, we are using Sophia as a smart contracts language of the aeternity blockchain. This is a functional, strongly typed state management and pattern matching programming language that includes at first-class objects, smart contracts, oracles, names, and state channels, making them easier and cheaper to implement. To write a smart contract, we usually need a simple text editor. However, there is the Fire editor contributed by Nikita Fudge that really helped us during the development of smart contracts, and it has cool features like syntax highlighting, real-time code debugging, compiling, and deploying to the test network. Later, we have the AE project, which is an aeternity framework that helps us with rapidly set up a project and interacting with the blockchain network. It provides a Docker containers for the local node and AE Sophia compiler that enables many operations by a useful command line interface. The AE project initialization sets up a boilerplate project that comes with the last tool of this section, the Ipfs JavaScript SDK, and other dependencies for deploying and testing smart contracts. This SDK is a framework to develop decentralized applications. With AE project, we also can initialize the Fire editor and an example of decentralized to-do application with Vue.js front-end called Shape. The common structure of a Sophia smart contract has compiler pragmas that enforce the contract to use a specific compiler version. It includes directives to import modules or external contracts and namespaces that help us to encapsulate code. These statements should live at the top level of the contract. Later, in the contract body, we declare the state, which is a record containing fields of different types that models data which will persist in the blockchain. It can associate other record types to define a more complex data structure. Then, we declare the init function that sets the initial state of the contract. This function is executed at the contract creation during its deployment. Finally, the contract body contains the functional part compound of functions and entry points that can be annotated to enable state mutation and spending transactions. Functions that are not declared as entry points can be used as internal helper functions. The Franchesca's use case. In our home, we have contracted Francisca to help us with the house cleanup. We use a regular paper contract and make a daily register by hand, signed by my wife and Francisca at the end of the labor day. Payments are done monthly according to the worked days, and when the contract has finished, we pay the settlement according to the law. This use case implemented this process with Sophia language, allowing Francisca to check in and check out with her wallet to register work days. At the payment day, the contract knows the worked days and calculates her salary. So, with this context, we now can see how Franchesca's contract was implemented. Let's take a first look of the public API that is compounded with the initialization function that receives the contract initialization parameters like Francisca's wallet, name, last name, citizen ID number, base salary for her workday, and the duration of the contract. There is a payout function that adds funds to the contract that will enable the contract spending at payment day. Also, the check-in and check-out functions will allow to register a working day. Finally, the contract has the pay function, which will process the chain spend built-in function. Additionally, these are public functions that are implemented in this fashion to allow calls from the test suite. Maybe not all of them should be public, but they were used to retrieve some values for debugging purposes in the testing process. We will see this structure in more detail later in the source code. With this in mind, we have two participants that interact with the contract. Those are the patron and the beneficiary. Each one instantiates its own AE client with the corresponding wallet key pair. The patron also acts as a contract owner who initializes the contract with its corresponding parameters. Once the contract is initialized, Francisca can start working registering her check-in at the beginning of the workday and check out when she finishes the labor day. Both functions mutate the state of the contract, storing a list of workdays that contains the blockade as time reference in the blockchain, and also the state of the flag that allows to know if she is working or not. Finally, the contract owner can make the payment at the end of the month, so she has to make sure that the contract has balance. When the contract is initialized, it has no balance, so the patron has to make a call to the add funds function. After that, she can make a payment with the pay function that calculates the salary and process the payment to Francisca's wallet with the chain.spend built-in function. If the contract does not have enough balance, the chain that spent transaction will fail. Let's see the contract source code and run some tests. Alright, now we have more understanding of this use case, the contract main structure and the process it executes. So let's start by deploying the contract following the next steps. In a command line shell, we will first start the aeternity node and the compiler with the AE project, running AE project node and AE project compiler. I have already run these commands previously, so this process ends with providing many wallets with some funding. These wallets has the public key and the private key. Okay. Once initialize the local node, we can say if that it provides us many funded wallets. Now we can initialize the file editor by running AE project file editor. I have already run this command and it deployed the application, so I can use it in the browser. It's awesome that it has saved the Franchesca's contract and it's available to start coding or inspecting. Let's see how is implemented Franchesca's smart contract. We can see that there are two includes directives at the top level. Those are standard libraries that facilitates the handling of list and pair data structures. In this case, there is no definition of pragma nor namespaces. Next, in the contract body, we can observe three custom record types for storing person information, workday, and payment registers. Note that each record has its own fields defined by key names and typed values. Also, note the association between worked days that contains a list of workday records in the payment record. The type state of the contract encapsulates its mutable state that is computed by the init function. This function returns the initial state of the contract once is deployed. It also can store values provided by parameters during its initialization, plus all the rest of the fields defined in the state that must have to be initialized. So these are the parameters provided during initializations. Later, we will find the entry points for check-in and check-out. These functions are annotated by the stateful keyword as they can mutate the state of the contract. Both functions have exceptions declared by the required built-in function that validates if Franchesca is working or not. In the check-in function, workday record is defined by the start and end fields with the chain block height and zero value respectively. That record is stored in the work field state of the contract. The checkout function checks the state of the work field. Right here. And if it finds that there is no value, will abort its execution. This means that Franchesca did not start to work. If it finds that there is some value, then we'll assign the value of the end key with the current blockchain height. Finally, the state will be mutated by adding the new workday to the list of worked days. Also, change the state of the is working fields to false. With these stored records, we could process the payment, but remember that the contract currently have no balance, so the patron should add funds to it. We can see the stateful payable entry point add funds. This is a simple function that gets the amount defined during the function call and adds its value to the total funds state field. Now the contract is ready to make an effective payment by calling the stateful entry point pay. This function makes two validations by declaring the required built-in function when the state duration field has reached zero value. This means the contract has finished. Also, it validates the person who is calling this function is the contract owner. Once these constraints are validated, the function will process the salary calculation and fetch the beneficiary address by getting the first value of the employee field. Note that here it used the pair standard library imported at the beginning. Next, the function defines the payment record registering the values of each of its fields like block height for the payment date, salary value to the amount field, and the worked days list. At the end, it makes the payment by calling the chain that spent built-in function and mutates the state of the contract with the payment info and remaining duration. If we scroll down, we will find some entry point functions that does not mutate the state of the contract. They are only defined to read data from the contract, and they are useful to debug values during the testing process. This contract has one private function at the end that makes the calculation of the salary. Alright, now we can run the test by calling the AE project test in the command line. This will run multiple unit testing that asserts the behavior of the contract. The first test it makes is the deployment of the contract with the initial parameters. It also adds some funds to the contract balance, so now the contract has this value in its initial balance. It also makes a calculation of the salary by hand that in the later test will be asserted with the real spent value in the chain. In this moment, the test is making a simulation of a working day. So in this here, Franchesca has completed a work day. This is the second work day. This is the third work day. And finally, Il will give us the current duration of the contract, as the contract has paid this value that corresponds to the calculated salary. The assertion is true, and the current duration rest 1. So let's see the testing file and make a brief review. Here we define some parameters. These parameters include the initialization parameters of the contract. Here we define both clients for the employee and the patron client, as we mentioned before. And these run the assertions that give us the behavior of the contract. So I want to invite you to check the repository of this project to learn more about it. Now, as this experiment, I want to make it work in my house to have a real use case proof of concept succeed. So we have done the initial contract functionality. Now I'm exploring the development of the front end with React JS, and furthermore, I think we need to improve more contract restrictions and test error handling, calculate the liquidation at the end of the contract, and integrate with a digital sensor. So I want to thank you for your attention, and this is the GitHub repository with this smart contract. And these are the credits of the icons. Thank you very much.
Thank you very much, Fabián, for your work. I think it's great to see how you can work on an almost complete solution. Speaking of smart contracts development and making the right use of all the suite we have available. Let's see if we have some questions. In the meantime, I invite you to get on the stage with me.
Hi everybody. How you doing? I'm sorry, my camera is not working, so I will be pleasure to respond to your questions right here.
Right, no problem. So let's see if we have some questions from the audience, and you can raise your hand anytime you like.
I think someone asked asked me to share the repository link, so I'm pasting it to the chat.
Thank you. We have one question from Tino.
Should I? I'll ask it. So looking at your presentation, and also like last week, there were some similar ones. It feels like it becomes very easy comparatively to have a verifiable process at the core, which is based on Eternity and which you've shown implemented via Sophia, a smart contract. But the hard part then becomes actually making that usable for anybody outside of the blockchain world, like your wife or
Yes.
the cleaner or whoever. So all the plumbing to make it into, let's say, a mobile app or product which people can start using seems to be now overwhelmingly much more work than like before, where this core process might have been a lot of work too, right?
At this level of the product, it's really difficult to a common person to use this contract, because it's more to the developers level who understand these interactions. But that's why the SDK, the JavaScript SDK, can help us to build front-end solutions that interconnect with the smart contract and allows to people who is not technical to interact with the blockchain. So that's why it's really necessary to work in a very nice front ends, usable front ends, to allow common people to use these products. So it's like having the back end and front end part of an application. However, in a most robust solution of blockchain, you can have backend solution, backend part of the application, front end, and the part that connects to the blockchain, as I explained it. So this application really is at the first stage of a useful product for the people.
Thank you, Fabián. Tino, I guess he answered very well the question, and it makes me wonder. We all have this challenge on getting our apps to get used by common people, right? And we came to them with some really hard things like address and 12 words and recovery phrases and a lot of things like that make the UX very, very hard. It's something that we have to face every time. And at least this is my opinion on this, is that we won't get a better UX for that, but people somehow is going to be it will be get used to that kind of apps. If you like, and if you want to have more power or more control on your information and your data, well, you need to do some previous step to that, right?
Yeah.
What do you think about that, Fabián?
Yeah, we have this is very, it's not that hard process, but this is a product that has many parts to reach an usable version. So I think it's very fascinating as developers to explore the different ways to reach that kind of usability. We have many examples, like the to-do list provided by the AE project, the AE project ShapeView.js, that give us a first part of this kind of experience. And now, if you work with single-page applications frameworks like React, Vue.js, and Angular, as the file editor is implemented, you can see that you can get a very nice usability level.
Yes, of course. For us as developers, it's really easy to get into this and to get results and to get a working app. What I mean is that once I have the app ready, has everything has front end, even have a mobile app if needed. I will need that somebody that doesn't know how this works to understand.
Yes.
And maybe sometimes we take a lot of work on explaining even what blockchain is, how it works, how important it is to have all these good things. But still, it's going to be hard for them to use the app the first time. You know,
yes,
they are.
It could
That's what I mean.
Okay,
but
okay.
We will have to work on that, and we will have to explain to people to adopt this technology more and more and more. So.
Yes, that's true. Yes, that's true.
Okay. Any other questions around here? I have another one.
I have one question or more a statement.
Yeah.
Yeah, I think looking at these last two presentations and the ones from last week, it's really exciting to see how far you can get with the Sophia smart contract. And
Thank you.
How fast you can get that core functionality going. So going forward, I guess, as a community, the challenge will be to make that highly accessible, you know, with all the tools on top of it, with the developer tools like the SDK and wallet and so on, to make it easier to get all of that plumbing on top, you know, working as easily as you actually get the core contract working. So that's really cool.
Okay, thank you. Yes. Yeah, I that's why I invite you all to clone this repository and start by making some changes, and maybe we can discuss more over this implementation. And well, regarding to the front end part, I'm not a React expert, so I'm just trying to explore this framework. And as we don't have already an example with React, so maybe this can contribute to React developers to develop front ends, better front ends, or more usable front ends with this technology, and integrating them with æternity blockchain.
Okay, cool. Got it.
Yes.
Last question for me.
Okay.
And I will let you go.
No, don't worry.
But creating the test suite, all the tests you are working on is very important. And actually, I think it takes a lot of time, a lot of work to make them. And for me, it's maybe the most important part, because I have to be sure that my smart contract doesn't have any flood, any bug, or any kind of situation. I don't know. And how do you think your tests? How do you think your tests?
Okay, testing is a very important part of the development process. As we need to prove that the data workflow is working as expected. So, to be honest, this is my first approach to testing with Chai. The Chai library is a test suite for JavaScript, and it's very easy to use. So, as Emmanuel did, it's a great approach using the file editor, because the file editor helps you to identify earlier errors during your code process. But when you have ended the contract's functionality, you will need to retrieve the information and try to simulate these scenarios to that will allow you to, or will make you clear to go to the next step, that is the front end construction. That will with this you will have a solid foundation of your code that will work without problems in the front end. So you can start by thinking in what is the scenario to test. In my case, I want to simulate Franchesca's working days. So I had to iterate over the pay function 3 times to get that behavior. Okay. Another important part is that you can simulate the clients. You can instantiate the clients that and make sure that they are hooked together with the contract, and later working it with them in the testing functions.
Awesome. Yeah. It's really important to have all your scenario tested and knowing exactly all the options that you may have, so you can be sure that smart contract is good and is working fine. Because once you are publishing it, once it's deployed on the mainnet, and you already have information on it, and then it's a little bit too late. So unless you have a process to skip that, but we have to test everything we do on smart contracts the best way we can.
Yeah, you really don't need to test everything, because it could be very expensive and very hard work. But you can define some scenarios that really that can be important to be tested. So you can focus in some scenarios that maybe will need to get information of some functions in the contract. That's why in this contract we have a secondary API that give us that allow us to fetch information from the contract. So those helper functions are very useful to elaborate our scenario in the test suite.
Cool, awesome. Well, thank you very much, Fabián, for your presentation and for answering all our questions.
Okay.
I invite you to stay here with us, and so we can move on the Ask Me Anything session.
Okay, cool. Thank you, guys.
Thank you.
Thanks, Fabián.
Thanks.
Okay, well, now we have our Ask Me Anything session. We will have Filip Piwowarski and Ulf Uyghur. I will present both, and then they are going to come on stage with us. So Filip is a æternity smart contract and code developer. Filip is a long-time blockchain enthusiast and a software developer. He loves to bring passion and knowledge into everything he does, as long as developing scalable and innovative solutions and educating others about technology and blockchain technology in particular. And Ulf Uyghur is the æternity code developer. He's a senior specialist in architecture and design of carrier class systems. He had the rare opportunity to influence a world-class product from conception through product release and several years of features upgrades and maintenance. He has been in this rodeo a long time, and he has a lot of experience. And finally, a significant technology shift. His previous experience includes architecture and design of decision support technology for the US DoD and the Alaska Integrated Incident Management System, and he worked in both small startups and large corporations. He has a special interest trying to bridge the cultures of research and open source development, as well as industrial design. Thank you both for being here. I see Pivo. Hey, Pivo, how are you? Let's see if we have Ulf. Ulf, are you there? On the meantime, guys, please send us the questions you have. You have people here to make uncomfortable with very tough questions.
Hello, everyone.
Hello.
So I have two questions. The first one is making use of a decentralized app on Eternity blockchain without making use of base app. So we tried using the reverse iframe method, but for some reason it has not been working, and we haven't seen any other method to use.
Yes.
Because I tried the Superhero platform recently, and I noticed on the website, they make use of the wallet extension. Once you download it, if you make a call, if you want to, let's say, retip a tip, the wallet extension pops up with an iframe saying you should confirm and stuff. So we want to make use of something like that, and we've not found a way around it.
Yes, this is already working quite well. So there's two concurrent standards. The base app, how we did it was in the past, and what the Superhero wallet and Superhero website do is using the AEX2 standard, which was developed to unify how wallets communicate with apps in order to be more everything can work with everything, because the base app approach does only work on a mobile phone and on some desktop configurations. And with the way we do it now, it works with everything. So when you look at the Superhero UI GitHub, there's an explanation, and also in the JavaScript SDK, there's an example on how to use AEX2. AEX2 is the standard to communicate from an app to a wallet, and I can leave both of these things here in a second. And also, Keno published the app boilerplate, which implements the AEX2. Maybe you can ping me after the AMA has finished, then I will send you the links.
Okay, great.
Thank you.
So my other question is about state channel. We've been hearing about state channel, and some of us are really interested in trying it out, see how it looks, and maybe add it to one of our apps. But we've not really seen documentation on state channels, and even a place to get started with. We've not seen anything, and I don't know if there's something somewhere we can.
I think we lost Jet. That's why he's coming back.
Yes, that's right.
I think we lost him again. On the meantime, we have some question about Jeremiah. Jeremiah, do you want to tell your question yourself, or do you want me to read? Don't be shy.
Just read, sir. Just read. I think if you read is enough.
Cool. Well, people, Jeremiah is asking if there is, at any time we can build a project completely on blockchain without using an external database, and how expensive can that be in a mining point of view?
Yes. So right now, you can of course build a product only on blockchain. For example, what we have done with the governance app does exactly this. Or you can use, if you have to store big amounts of data, you always use external data sources. Maybe what Emmanuel showed before, using IPFS is a good way, as you have a decentralized data store that's not owned by a central authority. This can be used, for example, as we do with a graffiti app as well, where the all of the state and data that we migrate and that define the rules and the smart contract on blockchain, and where the hard data, which is the images, are stored on IPFS for anybody to access both of the data and put together the artwork in the same way that our app does. And how expensive can it be? I mean, in general, the cost on Eternity is a fraction than what we'll find in Ethereum, so it's quite cheap, as long as you don't put all of your data inside, meaning put meta information that you need inside in order for your for the people that use the app to verify that it's doing the correct thing, and put big amounts of data, for example, images, somewhere else.
Cool. Thank you. We have another question from Marco. Guys, we need tough question for Ulf too. So try to think. Help me to that. Marco, you want to tell yourself?
Can you hear me?
Yes, we can hear you. Hey, Marco.
Yeah, it's again about a wallet connection, because I'd like to know whether it's possible to only use the mobile wallet that was recently released in the App Store and the Play Store without the need for an extension to connect to an app. Is that also possible? Because that's the way it's currently used on analytics with the base app.
So there's two ways that you can work with or actually 3 ways that you can do, and 2 that are implemented right now. So one is communicating from the desktop browser to the extension, and the other one is communicating from a mobile website using deep links to the mobile native app wallet using AEX2, and this also works for some requests. You don't know certain things because the callback using deep links is not possible, but this is how it's done right now. But I think using AEX2, you can also implement similar to behavior to what the base app is doing right now. There's just no reference implementation for this right now.
Okay, thanks.
I have the other question from Jet. Is there a document or use case for implementing state channel?
Maybe that's a good question for Ulf.
Yeah, well, in the protocol repos, you will find sort of technical documentation for state channels, and also basically a user guide that goes through the message interchange, essentially how you use the JSON RPC interface. Now, if you want to develop a state channel application, obviously also you would want to use the JavaScript SDK. And I guess at that point, I'm not really sure if there is that much documentation. So we are working on a state channel demo project right now that we're going to present pretty soon, where we will show how you can use contracts and develop applications based on state channels. So I guess right now there is a slight shortage of really reusable applications that you could look at and learn from. But so what specific documentation is I think there are some interesting games and payment applications built on top of state channels that you can partly look at. But what I think is really missing at this stage is sort of a stepping stone where you can quickly get to the point where you have you can start building your own stuff. Yeah, Tino mentioned the channel service. If you happen to be an Elixir developer, that is a very good stepping stone. And there is also a nice little interactive web interface there where you can fire up a Docker image. You can set up channels by entering initial parameters, and then you can watch the message flow and do signing and everything. So this is sort of a prototyping tool that we will very soon demonstrate. And we're also extending the Fire editor so that you will be able to do contract development in a state channel context. But also this is going to be demonstrated reasonably soon. So
cool. Thank you for your answer, Wolf. We have one question from Marco about the state of virtual state channel.
Yes,
Marco, are you there?
the state of virtual state channels. So we now have an updated white paper that is more, the previous one was more of a blog post sketching out what they would look like. The new white paper is more detailed. And one of the things that is absolutely central to virtual state channels is that we have to have a very smooth implementation of forced progress in the FSM. So we have been Dimitar is very close to completing that. I would say most of it is in there. The last pieces that we're putting in is that the FSM needs to be able to detect that a forced progress transaction appeared on chain. So there are a lot of cheating scenarios that we have to be able to capture. And our approach is that the FSM should be able to help the client. Essentially, if it detects a forced progress transaction on chain, it needs to update its eternal state. It also needs to inform the client and help the client respond to the forced progress if need be. And all that is pretty much merged now. And that, so right now we're focusing on the state channel demo project. And after that, we'll get cracking on the virtual state channels, I hope.
Okay, cool, thanks. But that will be consensus breaking, right?
Yes. We're going to have to introduce some new transaction types so that we can differentiate between the virtual transactions or virtual channels and the virtual channel objects and the actual on-chain channel objects. And some things are going to have to change on-chain as well for that.
Cool. Awesome. Thank you. I have. It's not so technical. My question is not so technical, but Ulf, what was your biggest challenge when you switched to the blockchain area?
Oh, for me, I guess the biggest change. I've worked a lot with distributed systems and fault tolerance. So I've done a lot of work on distribution or distributed algorithms, consensus algorithms, leader election, things like that. And one of the things when switching to blockchain, you become acutely aware of how much you rely on cooperation in practically all distributed algorithms. That there is an underlying assumption that the nodes participating in election or transactions or whatever are at least not evil. They may be buggy, so you have to be able to handle faults, and so that was the biggest change.
Hi, people. Carlos from Uruguay. How are you?
Hello, I'm good. How are you? Do you have a question?
Yes. I heard about lighting channels. I don't know if in eternity we've got lighting channels, or we are going to have them allowed to use.
Maybe this is also a good question for Ulf, as he's working with the state channels and also virtual channels.
So lightning channels are very different from what we're doing. I mean, they're pretty, bordering on absurd extension of unspent outputs in Bitcoin. And for one thing, they're payments only. And for one thing, they are already at this simple level so extremely hard to understand if you look at the implementation, that it's very hard to see that they can be extended any further. So what we have in Eternity is more of an actor style type of state channels that are where each participant in the state channel, they can do real-time communication. You have the generic messages, so you can actually have a lively dialogue in your state channel. And you can obviously execute contracts as well and do payments. So in the Eternity state channels, it's more like real-time, a real-time interaction channel where you can also do trustless payments and contracts. Now, if you would like to do some multi-hop, this is one thing that we've wanted to also look into. There is, with the JellySwap guys, built a hashlock implementation in a smart contract, Eternity or Sophia smart contract. And I think that could be reasonably easily modified to chain Eternity state channel sessions together so that you could do multi-hop transfers in a fairly more or similar to how other state channels are doing it.
Okay. Right. This is, I believe that these are for fast speed transaction, no? And well, with state channels, I don't know if we can reach these speeds in the amount of transaction that we can execute in each channel.
Well, speed of transactions, I think. So on one Eternity node, you should be able to service at least maybe 1,000 concurrent state channels, presumably more. It's the difficulty would be if you wanted to set up like 1,000 state channels in batch, possibly that you would run into some issues. At least I have tested setting up 1,000 concurrent state channels, and that wasn't. That is not a problem for the node. So, and say in each channel you can handle at least a few tens of transactions, payment transactions per second. you can handle a lot of transactions total, even on one Eternity node, and in the whole network, well, whatever limit there is, it's going to be very high.
Okay, thank you.
Thank you, Carlos. Thank you, Ulf. We have another question from Emmanuel about the event Sophia data type, and he was wondering how he should use.
Yes, so events can be indexed by third-party software, meaning if you throw the event, it will be returned together with your transaction call. And software, for example, the middleware, or when you fetch the transaction from the node, gives you this event as well. So if you have metadata that you don't want to return right away, that you don't want to store in your state, but it should be locked from your contract execution, you can use chain.event, use the event, and then later index it using the middleware or build it yourself software. There's an example how we use this in the governance app, where we find delegations in the past to not keep a full history in the state of the smart contract, but just index all of these events from the past and look at them in order to find what's the correct state, as it's more efficient than saving all of the data in the smart contract.
Great. I think there is no more questions, so I will thank you guys for being here and answering everything we were asking. And I invite you all to go to the networking track. We have one last thing about from Eric. If you have any suggestion for the developer track, please send us to the link that we have on the chat. Thank you all, guys, once again. I hope you see you everybody here next week, and we see each other on the networking track.
Thank you, Omar.
Thank you.
Thank you.
Bye-bye. See you, everybody.
See you.
Thank you.